Hello everyone and welcome to another tutorial. In this video you will learn how to create a game similar to well-known attack hole game. I will guide you through every aspect of the game, from understanding the mechanics of the hole to programming to collect bullets. Also I cover the boss fight as well. Let's get started. To make a hole, I will use a plain game object and a cylinder. The plane will be the ground and the cylinder will be the hole. We can use the stencil buffer to make it look like a hole. We don't need to modify the mesh filter itself. By using the stencil buffer as a mask, we can tell the GPU which pixels to render and which to discard. We need to set up the stencil buffer for each layer. Go to quality settings and choose a balance level. If you're making a mobile game, obviously you need to switch to Android. Then select URP balance renderer and make change in the inspector tab. It's important to uncheck the mask and mask layers in the opaque layer mask to properly configure the layers using the stencil buffer. To get started, select the Add Render Feature button and pick the Render Object Experimental option. Next, I suggest configuring the mask layer by assigning it a name such as Mask and selecting Before Rendering Opaques from the Event menu. This will give the layer priority for rendering before other layers. Once you activate the stencil, additional parameters will become available. To gain a better understanding of what the stencil does, I recommended referring to the Unity documentation, which provides definitions for each parameter. There is no need to modify the comparison operation back. It should remain in always mode, which ensures that the stencil buffer always renders the layer. Our next step is to change the pass parameter to replace, to write the cylinder pixel values into the buffer. Currently, in order to render the mask layer, you will need to activate it from the Filters section and then select it from the Layer Mask drop-down menu. To ensure that both layers are rendered at the same level of the stencil buffer, the mask layer's value should also be set to 1, similar to mask layer. The cylinder can be seen indeed from every angle, but we have a small problem. Even if we disable the mesh renderer, the cylinder will disappear. To fix this, we just need to make a simple custom shader that will make the cylinder transparent. We can do this by creating an unlit shader and turning off the Z-Write option. This code creates a subshader that sets the render type tag to opaque. This tag tells Unity that this subshader is used for rendering opaque objects. Then it creates a pass that turns off 0. This means that this pass does not write anything to the depth buffer. This might be useful for transparency or post-processing effects. Okay, let's make a new material and utilize this shader on the cylinder. Perfect. The cylinder does not render but has an effect on the ground. To entirely form it into the whole shape, we can simply reduce its scale from the y-axis. Okay, we have a perfect hole that can move across the ground. Now that we're talking about movement, it's time to add the joystick touch controller and the nav mesh component. I already covered a tutorial on the joystick, so I'll just show you how to use the written scripts. All you need to do is open the Unity to Brain GitHub, then open the new input system joystick asset and script folders and import these two scripts. Because the joystick benefits from the new input system, it is necessary to change the active input handling to new input package for the scripts to work properly. To fix these errors, we must also install the new input package from the package manager. Replace old input system modules with the new ones by selecting the event system and then clicking on this button. For the next step, we must add a NavMesh surface and a NavMesh agent to the whole game object, and then bake the NavMesh surface. If you want to simulate the touch input, you need to activate it from the input debugger window. The joystick works, but the whole game object goes in the wrong direction. The reason is that the camera is not properly adjusted. This issue will be fixed by altering the camera rotation. So far we've made a hole, but it's a fake hole. You can see the other side of the ground through it, but it doesn't mean a game object like a cube can fall into the hole. Unfortunately, the ground collider cannot allow this. So how we can solve this problem? We can write a simple script to change the layer of each game object placed inside the hole. First, create the script, then I'll demonstrate how two layers can avoid collisions. When a game object enters the trigger, its layer changes to a no-call layer, and when the game object exits the trigger, its layer returns to the default layer. The final step is to find the masked layer and no-call layer in the layer collision matrix and uncheck their shared row. By doing so, we tell the Unity engine that these two layers must deny each other and that no collision must happen. As you may know, the masked layer is assigned to the ground, and the no-call is also set to any game object that gets into the whole trigger. This is the moment that magic will happen and the cube will pass through the ground. Okay, let's try the script. The cube will pass through the ground perfectly, but there is one minor issue. The cube will fall immediately. That happens because of the hole trigger. In the next video, I'll demonstrate how we can fix this issue. Thank you for watching. I hope you enjoy it and I see you soon.